Welcome to the third episode of our series. Today we're going to talk about decisions before you start building your network. In basic topology, we're going to talk about how a network is going to look like and decisions behind it. In naming your devices and your network, we are going to decide what is going to be our naming convention and how that's going to affect how you can find the servers you have, services, and access it from outside. In networking equipment, we're going to talk about the different options to connect all the locations of your network, going through the pros and cons of each of them. For our network, we are going to have a mesh design, which means all our locations can talk to each other. Of course, if you have only 2 locations, that doesn't make any sense. But if you have 3 or more, you could have that the main location talks to all the others, but the others don't talk to each other. I don't know why I put this in the topology, because that has nothing to do with it, but here we go. Between IPv4 and IPv6, the main difference is that, IPv6 was designed to overcome the biggest limitation of IPv4, and that's the limited number of hosts. You can Google more information about it, but basically IPv6 should be viable for the foreseeable future, while IPv4 already has its ranges exhausted. I'm not going to use IPv6 for this project, mainly because one of my locations provider doesn't route IPv6 correctly yet. So I was having problems to keep the connections up correctly, and the failback to v4 was not working correctly. However, our design is going to allow for an easy transition to IPv6 in the future. Firstly, all our services are going to be configured whenever possible to use FQDN to talk to each other instead of IP. For example, when you configure a database, instead of one database server contacting the other using an IP, it will actually look for example, db2.yourdomain.com. So later, when the network infrastructure is ready for IPv6, you may have to do some firewall adjustments, but basically if the hosts can talk to each other, the services running on top of the operating system that has been configured correctly for IPv6 should work correctly. Also, we're going to choose network equipment that support already IPv6 natively. So later on, when we are ready to go on IPv6, after the provider gives me a proper IPv6 connection, I should be able to just have it running by ticking a few boxes and do the configurations I mentioned previously. Additionally, once we go on IPv6, if the underneath such software and services support encrypted connections via certificates or however, using IPv6 we should in theory be able to do the whole design without having VPN tunnels. That would simplify the whole environment a lot, but I'm not ready to go that way yet. Since we are going for IPv4, we should know what are the private network ranges. Wikipedia has a very nice description of what private networks are and the ranges. But in short, private networks are the ones that have addresses reserved for private networks. In other words, they are not publicly routable. We should avoid network ranges like the ones I'm showing on the screen. The reason behind that is, mostly when someone configures a home network, they will use the standard ranges. And if you decide then to run a VPN server and connect to your own home, you may have a conflict. For example, your friend's house has IP 192.168.0 whatever, and you try to connect using VPN to your own network that has also 192.168.0 whatever. There is a conflict there and it may not work properly. You may be able to connect but not reach the IP you're looking for example, or other issues. So I strongly recommend IPs like the ones I'm showing on the screen right now. So the chances of you getting into a conflict of ranges are smaller. You may want to segment your network by using network masks that will give you less hosts per network. If you're going to do that, I will assume you are a more advanced user and really don't need much of the content of this video, so look it up. One of the reasons why you may want to do that is, for example, to separate servers from workstations, or later on if you want to run, for example, VoIP between your house and your parents' house, you may want to segment the network so there is no broadcast traffic going between the networks, for example, and you get better performance. You guys know who you are, and if you're coming to the point where you decide to segment your network, I guess this series is not for you. So thank you for watching so far. When I started my own design 3 or 4 years ago, I had initially chosen some intranet.mydomain.com that was only valid in my network, on top of mydomain.com that was a valid hot domain name. But at the time I didn't have a very stable network, and sometimes the workstations or servers would have problems to resolve the names, and they would have issues talking to each other. When you would try, for example, mylaptop.intranet.mydomain.com, it would return the public IP of mydomain.com. So at the time, I rebuilt my own network using the format mydomain.lan, and since my design really expanded, I kept it like this. However, the more I looked on internet, more I found recommendations from people arguing and demonstrating very valid arguments why I should use intranet or whatever, or your site or site a.yourdomain.com instead of yourdomain.lan. You can look it up for yourself, and if I would be rebuilding my network with the knowledge I have accumulated over the years, I would use intranet or whatever .mydomain.com instead of mydomain.lan. But I leave it up to you. Either way, if you configure your DNS correctly, it should work. And I will try to demonstrate both approaches as we go with the series. For our core network devices, such as routers, gateways, and switches, I would use groups of countable objects, for example, Greek gods. Our main VPN concentrator could be called, for example, externally, zeus.yourdomain.com. So when you want to connect to your VPN, or when you want to connect two sites, you could get them connecting to zeus.yourdomain.com. Internally, they could be known as zeus.yourdomain.lan or zeus.site.a.yourdomain.com, depending on the convention you choose. So your internal devices will then find it by this internal name and resolve the IP internally instead of, getting the external IP. For servers and services, I would use non-specific names. For example, instead of calling a database server mysql.intranet.yourdomain.com, I would call it just db1.yourdomain.com. If you are opening external access to your webmail server, for example, Instead of using webmail.yourdomain.com, I would use access.yourdomain.com. That will make life a little bit more difficult for someone trying to attack your systems. Of course, they still can scan, try to find out what's behind, but at least you don't just give the information out easily like that. For virtualization service, you could just use vm1.yourdomain instead of using VMware or hyper-v.yourdomain.com. And if you're running a virtual server inside that server, I'm not sure inside is the expression, but whatever, you could use db1-vm1. So if you see an alert or something wrong with that server, you know where it is running. For your workstations, such as your laptop or your personal computer, and your physical service, standalone service, you can use whatever you like that describes best what that device is supposed to do or what that box is. For example, if you have an IBM ThinkPad or Lenovo, it has been a while since it was actually IBM, you could call just thinkpad.yourdomain.com. Your Power Mac G5 or your Mac Pro could be cheesegrater.yourdomain.com or .lan or .whatever you chose. And if you have a HP Microserver or HP Server G5, whatever, you can call it microserver.yourdomain or G5 or, VM-microserver, so you know that's a virtualization server running on a microserver, for example. Just be creative and choose whatever makes your life easier in the future. Now we are going to choose our networking equipment, more specifically the devices that are going to be interconnecting our sites together. I'm going to go through here pros and cons of out-of-the-shelf options, building your own, using, for example, mini PCs or Raspberry Pis. What are the advantages of software services, for example, Windows remote access services? And what if you virtualize your networking equipment, for example, running a firewall and VPN using pSense under a VM? Now we're going to discuss a bit of the pros and cons of the out-of-the-shelf devices you can find in shops. Out-of-the-shelf devices, they're usually smaller. They will pack more ports and the same functionality in a smaller package compared to, for example, mini PCs. Mini PCs can become a gaming PC, they can become a file server, so they are less dense in that aspect. Out-of-the-shelf devices are usually fanless, whether most mini PCs, or at least during my research time, they had fans. Out-of-the-shelf devices will have some manufacturer support throughout the warranty period, and they can potentially help you with configuration issues, for example. And most importantly, if you're lucky enough, your out-of-the-shelf devices will match your coffee machine and make your wife very happy. On the other hand, out-of-the-shelf devices are very unflexible. They do what the manufacturer puts there as a software functionality and are not expandable. For example, if you decide to attach a hard drive and turn your router into also a small file server, if you're building your own, you can just connect it there, install the software packages that are required, do the configuration, and voila, you're running. And if you take this out-of-the-shelf router that has no USB ports, there's nothing you can do about it. Manufacturers are not so keen for the cheapest devices to keep providing firmware and software upgrades to the entry-level devices that we are hoping to use for our projects. So you may end up having to wait a long time to see vulnerability issues resolved, or maybe never. And sometimes the documentation is horrible and they are very painful to get working. And throughout our series, we are going to have lots of examples about that. When you build your own, you are just bringing the parts to build a computer and installing the networking software you need for the functionality we are looking for. They can look however you like. You can buy Raspberry Pi, add LEDs, add status LCDs if you want. You can build a big one, a small one. You're just limited by what you find in the market and your creativity. There is also total software flexibility. You can install FreeBSD, NetBSD, Linux, and just install the packages you need for the functionality you're looking for again. It gives you flexibility to plan. If you build your device and later on you find out you need a proxy or a syslog server or a firewall, you can just go and add the functionality there. The internet is there to help you. You go to a forum, the forum of the software you're using your device, you can post your question and there is more than enough people willing to help. And also, since it's based on open source software, you have a smaller vulnerability footprint. Software updates are once they are available, you can just install them when you're ready. They can look however you like, however. So unless you really find all the functionality you need in a small box, you may end up having to add network cards for more ports, and you may end up with a monster. Usually, small bare-bone computers have one, and if you're lucky, 2 network ports. So if you want to build a small router with 3 or 4 ports for different VLANs, for example, you're probably going to have to add a network card and need a big case and a full computer. And unless you find a very small processor, I'm not even sure what's in the market nowadays, you have much more processing power than you actually need. So if you're looking for a single purpose device and you don't want to consolidate all your services into a single box, you may end up with a lot of wasted processing power and memory. Network as a software server has many advantages and disadvantages. They are easily bundleable, for example. You have your Linux file server and then you go install OpenVPN, done. You have a Windows Server box and you go and install the services for remote access and VPN, done. They are also upgradable with the rest of the OS, so if you upgrade your Linux box or your Windows box, you get all the security patches that will cover also the software service that's running there. And they should integrate nicely. For example, you have a Windows server, maybe you even have Active Directory, you go and create users, and you are automatically creating as well remote access users for the VPN server. And they are low on resource usage, yeah? You already have a server that has capacity, memory, and you just run one more service there, and you end up just using a bit more of RAM and a few CPU cycles without any issues. However, you become a hostage of your host OS. If anything goes wrong on your Windows installation or another service starts using your whole CPU, suddenly you may have a slow VPN tunnel or slow DNS name resolution resulting in very frustrating web browsing. It becomes a single point of failure. Again, you have a blue screen on your Windows installation or something like that. And then your computer crashes and there goes your router. Security upgrades can be very painful. Let's suppose you are running OpenVPN and there's a note that yes, you need to upgrade OpenVPN because of some security issue. You're going to end up having to restart your file server, your DHCP server, or whatever else you're running there just because you need to reboot for this security upgrade. You can also just add a new VM to your server and create a network device there. There are many pros. For example, it's build your own without any extra costs or very small costs. For example, you need a new router, you buy a 4-port network card, add to your computer, create a VM and configure whatever you need there. It has a very small footprint. You don't have almost any increased power consumption. You don't need more space. The software maintenance is easy. You can just create a snapshot of your virtual machine, try a configuration change or try a software upgrade, and if things fail, you can revert with a few clicks. It's also great for testing. You can clone a VM, you can do snapshots again, you can change settings, try and quickly revert if required. However, you are hostage of most of the console of build your own. Again, you need more ports, new network card. That would be basically it. It's not too bad actually. You're hostage of the host OS again. If you're running Hyper-V, Windows asks to be rebooted very often. If you're running VMware under Linux, you may have to restart under different circumstances. If some other VM suddenly is eating all your CPU resources, you may end up having slow network performance. And again, it becomes a single point of failure. Unless you have two virtualization servers with, for example, proxies or routers running on both servers, if your VM host dies, you may end up without your network. And if your relatives are relying on that for web browser, for example, you can make enemies really fast. At the time, I went for an off-the-shelf solution. Why? I thought of building my own routers and my own VPN concentrator, but I could not find a really decent box. The best boxes I could find were quite expensive, had only one network port, and I was not really a big fan of the idea of having a USB dongle hanging there. And they had fans. So I decided to go for the solution that looked good. The chassis is made of metal, and I thought it would be easier to configure as well. I'm happy with the performance, although a few features are lacking. But today I would really not go for off the shelf. Today I would really try to find a mini motherboard with 2 network cards and really build my own routers for all my sites, and maybe even bundle a few more services on that to, facilitate for my friends to really join my idea. So I'm going to start demonstrating the solution I'm using based on the Cisco RV router series, small business router series. They are based on some old Linksys platform that Cisco acquired. They look good, they are very stable, and now and then Cisco still releases firmware upgrades. But of course, as we go, I'm going to try always to show the open source solution and demonstrate them in virtual machines whenever possible. And here it is, my Cisco RV0482 together with a matching switch next to my 2 HP Microservers at my place. And here in this other video we have another RV42 across the ocean on top of my grandparents' home bookshelf.